Welcome back, everyone. I am so excited to jump right into today's explainer. We're going on a really fascinating chronological journey today. We're going to trace the actual path of scientific discovery, specifically looking at how chemical research travels from, those messy, isolated lab notes, all the way to perfectly polished, published breakthroughs that literally change the world. Because for centuries, chemistry was honestly just as much about deciphering terrible handwriting as it was about actual science. But today it's a journey of digital transformation, and it is absolutely critical for modern research. Think about it. For decades, the traditional laboratory environment relied entirely on hand-drawn structures. And the problem with that? Well, trying to decipher a colleague's fading, totally inconsistent lab notebook often left researchers completely isolated. It made experiments incredibly difficult, if not impossible, to reproduce. But the modern lab, it demands digital accuracy. As our experiments have gotten incredibly complex and extremely data-heavy, the tools we use have had to evolve to keep pace, prioritizing highly accurate and deeply collaborative workflows over just jotting things down on paper. Okay, let's dive right into this. Section 1, the digital chemistry revolution. To really grasp what's happening in modern labs, we need to ground ourselves in what this digital transformation actually entails. Basically, it's the fundamental shift away from pen and paper toward powerful software platforms. And one of the biggest tools driving the shift is ChemDraw. Now, this isn't just a digital sketchpad. Well, actually, scratch that. It is a sketchpad, but a really, really smart one. By using automated structure recognition, the software can instantly flag an impossible molecule, literally saving researchers hours of manual checking. It standardizes molecular drawing so that absolute scientific accuracy is maintained, whether you're working with the person at the next bench or a team at an entirely different institution. It's a total game changer for how chemists record and share information. Now, you might be wondering, why does this matter so much? Here's the harsh reality. Small errors actively destroy reproducibility. Let me be clear. In chemical research, accurate documentation isn't just a nice-to-have preference. It is an absolute necessity. A single ambiguous bond, or just one missing label on a hand-drawn molecule, can cost a replication team months of wasted funding and failed experiments. No way around it. The stakes are incredibly high, which is exactly why digital precision is no longer optional. Moving right along to Section 2, accuracy in lab documentation. Let's zoom in to the micro level, right at the lab bench. This is where reproducibility is forged. ChemDraw essentially acts as a safety net right there with you. It actively ensures correct valence representation, which is basically just making sure your atoms don't have too many or too few bonds attached to them. It practically validates the molecular structure while you're working. On top of that, it lets researchers build incredibly clear reaction schemes, mapping out the reactants, the intermediates, and the final products in a highly structured format. It's kind of like having a digital supervisor looking over your shoulder, making sure your scientific clarity is always 100% intact. Which brings us to Section 3, improving scientific collaboration. Zooming out from the individual bunch, we start to see how a standardized visual language is what actually connects people. And this brilliantly illustrates how teamwork happens across the hall and across the world. Because these digital diagrams are mathematically consistent, a biologist in Tokyo can look at the exact same reaction pathway as a chemist in London and understand it instantly. In practice, this means a massive reduction in ambiguity during scientific discussions. Colleagues across the globe can just collaborate seamlessly without the headache of deciphering someone else's handwritten idiosyncrasies. So what does this all mean for the big picture? We really need to ask, how does this fit into the broader lab? It's awesome to have a standardized drawing tool, for sure, but a modern laboratory is a massive, complex technological ecosystem. Let's explore that in Section 4, the modern research ecosystem. Modern chemistry doesn't happen in a vacuum. It requires a central hub. And this software seamlessly integrates with things you use every day: word processors, presentation platforms, and extensive chemical databases. This interoperability is huge. It means no more redrawing complex molecules from scratch just because you need to put them in a PowerPoint or a final report. Researchers can fluidly move between data analysis and documentation, which massively reduces manual effort and completely eliminates those frustrating errors that always seem to happen when you're converting files between incompatible systems. Now, what's really interesting about this is how this software pairs with electronic laboratory notebooks, or ELNs. By integrating directly into an ELN, research teams maintain a continuous, highly structured, and time-stamped record of every single thing they do. This protects the integrity of the study, which, by the way, is absolutely crucial for patent filings. It ensures that your data is accurately captured and easily retrievable, whether it's for an analysis tomorrow or a massive replication study 5 years down the line. And finally, Section 5, Achieving Publication Success. Let's move to the final payoff and see how this builds. This entire digital workflow leads to one ultimate goal: transforming your raw, accurate data into a published breakthrough. It's a literal progression. You start by capturing the research data. Then researchers make crucial visual tweaks. Because let's face it, top-tier journals are notoriously strict about formatting, so being able to easily adjust bond thickness and perfect the layout is a lifesaver. Next, you export those figures into the precise formats those journals demand. And boom, step 4, a successful publication with fully compliant, high-resolution graphics. It literally removes the friction from the final mile of research. So the crucial point is that this workflow isn't just for one specific niche. Mastering this gives everyone a competitive edge. Students use it to develop real practical skills before they even graduate. Over in pharma and biotech, it's powering cutting-edge drug design and complex molecular analysis. And for global researchers, it's the absolute backbone of cross-functional communication. Wherever you are in your career, this is the toolset you need. To wrap up today's explainer, I want to leave you with this powerful quote from the source material. It says, "Researchers, students, and industry professionals who adopt such tools are better positioned to succeed in an increasingly competitive and data-intensive environment." Adopting these digital workflows, it's basically non-negotiable at this point. It is the only reliable bridge between a messy lab bench and a world-changing publication. So if you or your lab are still relying on isolated analog methods, you really have to ask yourself, are you documenting the future of science, or are you already being left behind in its history? Thank you so much for joining me today to explore this vital evolution.